Okay, let's look at the situation one more time. Okay, so many theorems, many ideas, many limits are very, very simple if you recognize that they are derivative limits. Yes, so they relate to the derivative one way. So L'Hopital is this rule that tells you that if you find that limit as x goes to some number of one function equals to x to the limit of the other function, and that limit is 0, yes, that limit is 0, then the ratio of those functions is, the limit of the ratio of those functions is the same as the limit of the ratio of the derivatives, yes? Now, why is that the case? Very simply, limit as x goes to a of f of x over g of x is the same as limit where x goes to a, f of x minus fa divided by gx minus ga. Do you understand why I introduced fa and ga? First of all, I could do that algebraically because f of a and g of a must be equal to 0. If the limit, if I'm already talking about derivatives of those functions, it means they are differentiable. If they are differentiable, they are continuous. And that means that by continuity, limit and plugging in the value is the same thing. Are you with me? Right? Differentiability implies continuity. The fact that limit as x goes to a of f of x is f of a, that's continuity, and that must be equal to 0 by hypothesis, allows me to just put it in. Now, what am I doing? All I'm doing is, again, I see, as the more easily I see the definition of the derivative in things that don't right away look like the definition of derivative, the better I am. Good? So here is what I do. I begin reconstructing this mess. I'm just kind of sorting the bones of one function from the bones of the other, the bones of the definitional derivative of one function from the other. Do you now see how I brought it to this form? Again, guys, you would not be able to do that if you are not, if you do not have a goal in mind, if you're not sure where you are walking. Are you sure where you're walking? Yes? You understand how already when I begin doing it, I already know where I want to arrive. I'm searching for the pattern f of x minus f of a over x minus a, and the corresponding pattern for g. Here they are, yes? And what do I end up seeing then? The first part is simply f prime of a, and this is 1 over g prime. This limit is the limit law 1 divided by the definition of the derivative for g. Yes, which if I want to, if the derivative is continuous, I can also write like this. That's it. You understand that you understand L'Hopital without anybody needing it to be taught to you, if you are realizing what it really is, nothing more than recognition, okay? And that's a very convenient type of recognition, so I don't have to do reconstruction every time again. So here is an example. So suppose you want to do limit as x goes to, and then we'll go back to one function, one equation that I skipped. Limit as x goes to 0 of cosine of pi plus x minus cosine of pi minus x divided by x, okay? Suppose you have this problem, okay? I can reconstruct you see its numerator is 0, denominator is 0. Do you agree? So it's 0 over 0. So it is in L'Hopital form. When you see 0 over 0, you think definition of the derivative. But because I had this theorem, I just established a pi on the bottom. Well, actually, x is going to 0. You don't need a pi on the bottom. You can see that this goes to 0. So I can do this. I can reconstruct the derivative from the definition. I can do it from the definition, or I can already use L'Hopital because I already figured how to do this process. I mechanize it. You understand? I make it mass production. I already did it in the moment ago. I did it in a general situation. If numerator function approaches 0, denominator function approaches 0, then I can just take the derivatives of each. and then take the limit. Yes, that's what I mean by mechanizing it. So I don't have to do the assembly of the definitional derivative all the time again. So I create shortcuts upon shortcuts. Thank you, Alan. It does. You understand what I'm saying, guys? So do you see that numerator approaches, you see, because it's going to be cosine of pi minus cosine of pi if x goes to 0. So this approach is 0, and this approach is 0. So I can apply L'Hopital. Yes? Again, applying L'Hopital is just, I mechanized the idea. I could recognize that this is the definition of a derivative, but I don't want to bother with it all the time again and again. Yes? Are you with me? So I have a shortcut upon a shortcut. So what is this thing? This thing, and I can write the symbol to indicate I do L'Hopital. It is the limit as x goes to 0. Derivative of cosine is minus sine of pi plus x. Minus sine of pi plus x. Good. That's the derivative of cosine, and then I use chain rule. The derivative of pi plus x is just 1, and then this is minus, but derivative of sine is minus. There are going to be three minuses. There is this minus, there is this minus, and there is the minus coming from cosine, so it will be minus sine of pi minus x. I hope you understand how I did it, right? Derivative of cosine is minus sine, and then times another minus is sine, and there is this minus. Altogether you have minus sine pi minus x, just basic algebra, yes? Divided by 1. Now I can plug in 0. So what am I gonna get? I'm gonna get minus sine of pi minus sine of pi, altogether minus 2 sine of pi. And sine of pi is 0, so the answer is 0. Yes? Do you follow? Some of you look very sad. I do not understand. You might you're touched by the beauty of mathematics. It's like classical music, right? And it moves you to tears. Now solve this one. Yes, of course. Last step is this. I just take the derivative of the numerator. Can you take the derivative of the numerator function? And be careful when you take the derivative of the numerator function. When you take the derivative of the numerator function, you get minus 2 sine of, well, sorry, actually, you get minus sine pi plus x minus sine pi minus x. That's what you will get. Good? You will get minus 2. And I would actually know it because I will do it abstractly. I will not do it for this problem. I would do another shortcut to make it even faster for me. Okay, this is what how I think of such problems. Let me show you how I think. Okay, so I look at it and I think something like this: what is limit as x goes to 0 of f of some number a plus x minus f of a minus x, that's the general pattern, divided by x. by L'Hopital's rule, if the function is differentiable, it will be limit as x goes to 0. Numerator is derivative f prime a plus x minus f prime a minus x, and because there is a minus x, the derivative is times minus 1 divided by derivative of x is 1. That's the L'Hopital part. They do apply to limits at infinity, but to establish them, you have to kind of passively, you can think of in complex analysis, right? There are many other, it's not the full story here, right? So there are other things that you don't know right now. But it does apply to limit at infinity as well, just you don't right away see why. Somebody asked me this question. Okay, so this is what? So this is limit as x goes to 0. And what is it? It's just 2 f prime. Well, it will be this. You see, just when you take the limit now, x is now 0. So it's the answer is 2 f prime of a, of that function here. In that case, it's twice the derivative of cosine at pi. So in my case, it would be twice the derivative of cosine x, where x is pi, which is 0. Okay. Here is this one question. Can you solve this one? Beautiful. Beautiful. 3 people here. And you'll begin to see. Very nice, Muhammad. 4 people now. Five. 7. I think 8. Nine. Okay, in a moment I'll show you how I think of it, yes? Ten people. I'm still missing some. I didn't say it's not similar, right? Maybe it's very similar.
I'm trying to tell you.
All right, are we ready? Let's go solve it together, or you still want to work on this question? If you still want to work, don't be shy. Just write in the comments that you still want to work. I don't want to steal the victory from you. Right, when you ask me, can you do it another way? The answer is always yes, you can do it in infinitely many ways. But sometimes the question, can you do it another way, sounds like, do I have to open the door? Can I not just bash my way through the wall with my head? You understand? So there are many ways, right? What you're trying to do is you are trying to come up with the clever solution. If you find something that solves the question much faster and it's not Wolfram Alpha, then by all means. All right, so let's get ahead. So here is I look at it and I see that e to the, it would be when I plug in minus infinity, it's essentially e to the 0, and here also e to the 0. Do you agree? E to the 0. Yes. Which is 1 minus 1, it will be 0. So I think there will be some benefit in, instead of multiplying by x, dividing by 1 over x. Yes. So what I do is this: I have limit as x goes to minus infinity. e to the 1 over x minus e to the minus 1 over x divided by 1 over x. Yes? And then here is what I'm doing. I'm going to use the same symbol. It's up to you. If you want to, I'll use another symbol. You let me know if you're confused. I look at it and I see the meaning. I'm not looking at the symbols, only the meaning. So that's the same as limit where x goes to 0 of e to the x minus e to the minus x over x. I simplified it for myself. It's the same thing. Why? Because doesn't matter what there is no x is just numbers are going to, this number is going to minus infinity. That causes the power for e to go to 0. Yes, right? If you want to, if you're very nitpicky, you can say okay, what is this? This is a negative number, so you might say x goes to 0 from the negative direction if you prefer. Good. It's not going to matter for the problem. Understand? Guys, this is an important step. Do you understand how I went from this line to that line? It was not by algebra. What I did is I just read the meaning and I wrote the meaning again using the same letters. It's called abuse of notation, you know. It's still not reported to the police, but you know, you can therefore still do it. Abuse of notation, yes? Just keep quiet about it. So what I did is not algebra. I looked at this expression and I read it. I translated the meaning in my mind and I wrote it again using the same symbols. I could have used other symbols if you're bothered by same symbols. So good. And then I see numerator goes to 0, denominator goes to 0. I can apply L'Hopital. Victoria, why over? Because then I see 0 over 0. This part in the parentheses goes to 0, but this part goes to minus infinity. When I divide by 1 over x, look at it. So this part goes to 0. Denominator goes to 0. Numerator, it's like 1 minus 1, also going to 0. Do you understand? So when I see 0 over 0, I right away think derivative or L'Hopital, which is again recognition of the derivative. Just I made a shortcut there, right? And so here I apply L'Hopital. So this is limit as it goes to 0. That would be derivative of e to the x is e to the x plus e to the minus x divided by 1. And when I push 0, it's e to the 0 plus e to the 0, which is 2. That's it, I'm done. It's 2. The answer is 2. You follow how I do it? Now, all the questions I showed you for the past hour, they're the same question. If you realize it, then you see that we were solving the same problem. Good? Any further explanation at this moment for this type of process? One last one? Okay, sure. There are no, see, here is another one. Okay. I'm giving at infinity. It could be at anything really, right? I'm gonna something do this thing. Yes, Alexei, very good explanation. Let's say this, okay? Limit as x goes to infinity, e to the sine of 5 over x minus one divided by, well, multiplied by x. Okay, Alan says 0. Thank you, Kirill. So James, you mean the first answer or the second answer? Wonderful. Of course, one can be changed to e to the 0, Alex. Why would you doubt it, right? E to the 0 is the same as 1, so you can replace like by like or identical by identical.
I would say because we have a limit of e to the power of x, where x is approaching 0, so it's almost 1 minus actual 1. So we know it's a real 1, but we don't know how how close the limit of 1 is. So you could still get a different answer from that. You would get a approaching like 0 or something.
So when you do that again, again, you should always expect in this class that many limits, the reason you can solve them, that they look like derivatives of sorts. When they do not, then the limit can be very difficult. Right, guys. In a minute, let's solve it so that we can do a little practice with the final questions. Yes, because we're doing this thing already for an hour. All right, let's do it together. Where did you all go? You all disappeared from me. All right, let's solve this question. So first thing I see that numerator is, sorry, numerator, what's in parentheses is approaching 0, yes? So I'm going to divide by x, and I'm going to say limit as x goes to infinity, e to the sine of 5 over x minus 1 divided by 1 over x. And because I don't like to have 1 over x here, I want a 5 here. Can you see that? So I'm going to see several things here. When x is going to infinity, 5 over x is essentially 0. And sine of a number close to 0 is not altered by much, right? That's what we verified from another limit. So what we have here, I put a 5 here. And to cancel that 5, I put 5 here. So what I now see, this and that are the same. And sine is not doing too much. So I see that this is limit as x goes to infinity, 5 times e to the, I would say x going to 0 actually. Let's just change it. X going to 0, e to the x minus 1 over x now. You see, I changed the meaning here. And now it's the definition of the derivative of e at 0. So that is 5 times 1, which is, the answer is 5. And do you understand? We can solve more such problems later on. But the answer is 5. I go through all sorts of processes. I just understand that sine is not doing much to numbers close to 0 if they're in radian measure. So I can ignore it. And yeah, I can do it other ways. But the point is that I can look at the answer and right away see the answer is 5. I don't need to think too much. Carolina, you are leaving, but we haven't yet done what, when, where. Okay, well, if you have to leave, you have to leave, right? At what, when, where, we definitely have to play around of that game. The time of the review session, well, let's do this. If you have a moment now, I will show you one question. What do you say? I will show you one question of that game, tell you how it works, and if you want to play it afterwards a little bit longer, we will do that. Deal? All right, guys. Yesterday they blocked my video because apparently I'm not allowed to record this. So I'll pause the recording. Actually, first I will show you the game, explain about it, and then we will play. Okay, it's a 1 round or something. Are you ready? Let's go. 1 round. get ready, guys, right? And then we'll do the review of a few questions. This question I really liked. It's about Canada and the United States. Okay, so let me explain to you the idea of this game. So you have a club of very intelligent people. They're specially selected. It's like a Mensa type of thing, right? It's popular in Russia. And those that play this game very well, they are in this club. They are called knowers. They are good at solving riddles. That's pretty much, they have teams and they're good at solving riddles. The audience, and the audience is not necessarily, they're not present in the club. It's like you can send questions. And if your question is good enough, it will be screened and it will be presented on this show. And if you are able to cheat those people out of answering your question, in other words, if they're not able to find a solution to it, they get, the audience, the person that asked the question gets money. Okay, let me show you one question. I'm gonna pause the recording. Okay, pausing the recording. Okay, so we are doing Calc 1. Here is the way your exam looks like. You see, similar to the way I tried to teach you, I hope. So go ahead and solve problems. Well, basically all the problems you see here, okay? Blah, 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 all those problems, solve them. We know that the limit of f is 12 and of g is -8. Solve those questions and do it fast, please. If you can come up with a good riddle, right, let me know. We can send them the riddle and see if it might be featured in the show. Come on. What's the answer to the first? F of x gx. What's the answer? I mean, it should not take forever. Come on, come on, come on, come on, come on. Meow, 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 meow.
So I'm assuming we just plug them in, right?
Well, I mean, why assuming? I mean, you should be certain what we do.
Well, I don't see any problem with that, so I just did that.
Okay, so what's the answer for first line?
Negative 96, I think.
Yeah, well, I'm gonna just write it. You see, unless you have to do algebra and you're made to do it, so you just write it's 12 times minus 8. I don't really care for the number. Yes, you can multiply it, sure, right? You can say anything you want. You can say 80 plus 16 or 90 or negative 96. But why you worried? Okay, look what happens here. X goes to 3. F of x becomes 12 like, g of x becomes minus 8 like. So the product is 12 times minus 3, yes? You should not always expect a trap. Just look at it and think what's happening.
It's just that after in your class, you know, it's almost like every other question is a trap. So at this point,
yes, but you are taking the wrong impression from my class. It's not my thing is not the trap, is the thinking, right? Think about it, right? Now, what's the question here? What's the answer here?
0, I think.
0, beautiful. Good, beautiful, it's 0, yes? Guys, it's not the trap in my class. The trap is to show you what? Why did I trap you? Is to show you that you have to think, right? So they are not trapped, right? You don't have to be always thinking that you are wrong. You just have to look at it and realize what's happening, what you should have a process. What is the answer for it? It says this does not always exist. I don't know what he means. Okay, so what's the answer for this question? So for this one, what's the answer? Okay, good. What's the answer, guys? You have I have 13 of you here. I'm not sure.
I got negative 1.
Okay, maybe so. One person says negative 1. Write your answers in the comments so it's written in blood. Good. So come on, guys, should take you a second to recognize it. Okay, Edwin, thank you. What's the answer to this? Yes, yes.
Yes.
Okay. So James and Edwin, 3 people are in the 0 club. Some people are in the 1 club. Alexei is in the -1 club.
Oh, I see what I did wrong. I thought it was derivative of sine is negative cosine. Never mind.
Okay, are we getting there? So let's look at it together. What is happening here? It goes to 0, yes? And this goes to 0, yes? Yes? Goes to 0. So it's sine of a number that melts to 0 divided by the same number that melts to 0. And so the answer is 1. Why is the answer 1? It's obvious, because you look at it, it's really, to me, it's the same as limit as x goes to 0, sine x over x. That's, again, we're back to always the same problem again and again. It is, don't pay attention to the letters. What's happening? What's inside of sine melts to 0. You divide by the same thing that melts to 0. So the answer is obviously 1. Because that's the derivative. This is just the derivative of sine at 0, which is cosine of 0, which is 1, if you have to remember it. Does it make sense? The next question is too boring to deal with. Yes, you look at it, you right away know what to do, correct? Yes, that's rhetorical. The answer is correct, right? We don't need to do this question. What is this? Question 3. You get on an airplane in Los Angeles. The plane leaves at 9 a.m. and arrives in New York 6 hours later. Note that both cities are at sea level. Party to go to? All right, Kirill. You don't like this party. It's lame, I see, right? Not enough noise. Take care. You get on an airplane in Los Angeles from 9 a.m. 6 hours later, blah, blah. Let HT be the altitude of the plane in kilometers above sea level, T hours after 9 a.m. Due to a malfunction in the flight data recorder, possibly caused when the plane flew over Area 51, some of the data was erased. A graph of the data is shown below. Are you ready? Here is the graph of the data. That's the altitude of the plane against the time of flight. Are you with me? Use the graph and your knowledge of the real universe to answer the following questions. Is h of t a continuous function? Why or why not? Come on, guys, it should take you a second, right? What they want from you, like blah blah blah. Just quickly.
Isn't it continuous because it never because it tells you in the problem that it landed. I forgot the question already. It didn't really land it. It just kept continuing going to its destination.
How do you recognize continuous motion, right? So when you say continuous or not, what is continuous motion? Have you ever watched old movies as opposed to new movies? Have you seen black and white, silver screen movies, Charlie Chaplin movies? They go, right? What's so strange about those movies and about their motions? Is this, right? Continuity of motion is when I take many frames, the motion is gradual. There is very little change from one frame to the next, right? This continuous motion is from one frame to the next. There is huge change. That's why you are terrified when you watch those horror movies, when you see some sort of thing very far out at the end of the corridor, lights flickering, and then the thing is right next to you. Yes? You understand why you are scared when you see, like, let's say some maybe, I'm not sure what it is, Woman from the Rings and whatever horror movie. So something is standing very far from you, and then light is flickering, nothing happening. Light is flickering, nothing is happening. And then suddenly it flickers and it's right in your face. Because you realize that it's not a continuous function. You're terrified of the mathematical implications.
Just by the way that airplanes fly, there's no way that it couldn't be a continuous function because it would have to like jump like a lot higher than, like it would have to be like I don't know.
It would have to teleport. So basically, in the real world, you think of not continuous functions as teleporting. When you teleport, you are undergoing discontinuous motion. You hear how somebody is suffering?
I mean, we don't know what happened during that time. I mean, anything could happen, really. So. Yes, we don't know what will happen. It's Area 51, so you might say if it's a sci-fi movie, there was teleporting. But if the travel was regular, you might say it's continuous. It's a why or why not. You can answer it many ways. You're not forced to have one solution. Why else would the data not be available, you know?
Exactly. Maybe it teleported. So you might say it's not continuous because your knowledge of the real world is that it's Area 51 and lizard people control the government, which is true. Good. I can show you some interesting things and see how your critical reasoning is working if you're interested, if you want to make it dangerous for me. Okay, I'm going to let him out. He's suffering. Do you want to see him before I do, or just let him out? He's crying. Poor thing. All right, you don't want to see him, so I'm going to let him out. All right, moving on. So calculate limit as t goes to 2 from the left, that's 2 to the minus, and 3 from the left. Come on, fast in the comments. Should take you 2 seconds. Here is the graph, here are those limits, come on. Whoa. Some mathematician, I can't remember which ones, wrote, I think Hermite, I shudder at the horror of discontinuous functions. 12 or 0. So this limit, well, look at it. The limit, if you go from the left, look at the curve, ooh, it looks like you're going to 12. You agree? I mean, slightly below perhaps, but let's say 12. You see that? Limit from the left is 12. If you go, and then if you approach 3 from the look at it, there is a 3 from the left, no idea. Because 3 from the left, we don't know what's happening, right? From the left of 3. We know from the right of 3, it will be 8. But from the left of 3, no idea. Are you with me? There is no data here. I do not know what's going on here. If the function is continuous, if you answer that the function is continuous, then the limit from the left of 3 is the limit from the right of 3 and will be 8. Do you understand? But if you assume the function isn't continuous, you have no idea. Clear?
So is it continuous or not?
Well, that's the mystery, right? That's how thrillers end. Was it mystery solved or not?
So according to real life, it is continuous, but according to
real life, it's not clear if continuity makes true sense. It's an approximation to reality, right? As von Neumann said, mathematics is an approximation to reality. That's it, right? So if you believe the curve is continuous, then the answer is that this limit is 8 because it's the same as from the right. If you believe the function is not continuous, then that's something else. Good?
There's 2 answers to this question.
There could be infinitely many answers to this question. You look surprised to me. Guys, do you think that there is a right question, right? Do you have that mentality seriously? Do you believe that there is a right question? There is a right question possibly from assumptions that you're making, but assumptions are very important. The assumptions can always be, that's why everything is a theory, right? In theory, you exist. In theory, I exist. There is a theory of relativity. There is a Newtonian theory. There is quantum theory. It's all called theory because it is true to the best of our understanding or someone's understanding, right? If the function is continuous, the answer is that the limit is equal to 8 for t going to 3 minus. If the function is not continuous, I have no idea what it is. Good? I think the function is continuous based on that gradualness, right? If I videotape the airplane from one frame to the next, there is little change, and if I make more photographs, there will be even less change. So that gives me evidence of continuity. But is it conclusive evidence? What about if I divide? Can I divide time forever? Oh, see, you can go and ask who knows what questions, right? Now find the limit as t goes to 6. 6 is actually, what is it? Not 6 is not a typo or a mistake to this question. Find the limit as t goes to 6. Here is the graph, and here is the information. Your airplane is moving from Los Angeles to New York. Both are at sea level. Do you understand? What's the limit as t goes to 6? Wonderful, Christian. Yes, exactly. You landed. In the limit, you will be back to the ground. From, how do you say, from the ground you came into the ground you go. Find the average rate of change of the altitude over the interval from t equal to 0 to t equal to 6. I think, well, the average rate of change, you can kind of suppose skip this question. It will be the integral of this curve divided by the length of the interval, but we do not what is it, the average, what is it, what are you asking? Sorry, find no find the average rate, the average change of altitude. I'm sorry, no, what's the average change of altitude from 0 to 6? How much did the altitude change on average?
Yeah, is it 0? Because it went from 0 to 0?
it went from 0, so that's the displacement. So the average, how should I say that, the average altitude, when it's a bit, when you say what's the average altitude or the average altitude change, it's a bit a confusing question. I'm not sure I understand exactly what is asked, right? It might be that they are asking, it went from 0 to 0, so so that is just 0, good? It might be something that I'll teach you starting Tuesday. We will be learning integrals. Yes, we'll be learning integrals, and then we will do that. I need to send you videos. You need to watch lots of my videos so that you
Hey,
you
that's
know
not how
everything about it. Sorry,
That's not how planes fly, I don't think.
that's what?
Is that a good representation of how a plane flies?
I don't know. It doesn't matter to me. It just the airplane took off, had a big altitude, went down.
Yeah, in like an hour it went.
This when you say average, maybe from this point to that point, maybe that's what he means. I'm not sure what do they mean by average rate of change from where to where. Do they mean the slope from this to this? Then it's 0. I'm not sure what the question means. Okay, we can get to it back. True or false? At some point between T2 and T3, the plane's altitude was exactly 8.275 kilometers. So let's see that between t equal to 2 and t equal to 3. So t equal to 2 and t equal to 3. Exactly 8 point something, right? Yeah, so when we're assuming, let's say this. This is the intermediate value theorem. Yes, you see that? Intermediate value theorem. Yes. If it's continuous, then intermediate value theorem, you had to go from here, which is 12, to here, which is 8, for all the values. If it's continuous, then it's true. So Christian is answering it exactly as I think of it. If continuous, then yes. Good. Which of the following could be used to answer question, how rapidly did the plane descend during its last half hour in the air? Okay, we want to know. So in A, I'm assuming that's A here. Oh no, it's B. So A is how rapidly during the last hour was the airplane moving in the air. So A is h of 6 minus, that's altitude at 6 minus altitude at 5.5 in the last half an hour, right? Or this, or whatever else. Which of those would you select, basically? So again, A is this thing, right? It's this h of 6 minus h of 5.5. The question is how fast? Okay.
Yeah, but it's asking for the t of time, right? So we don't have 6 or 5.4, so we don't really have the information.
Yes, but how, whatever, if you had the information, which one would it be? Because the graph is not showing all of it, but which of those will be, if you had the full recording, right? This is just showing you part of the recording. If you had the full recording, how would you measure the average speed for the last half hour? That's the question.
Okay, all right.
Okay, so what's the average speed? Is the displacement in position divided by change in time. So exactly, the answer is B, right? Everything else is just a difference in, well, first of all, C doesn't make any sense whatsoever, right? C is just, I'm sorry, it does. It's just half an hour thing, right? So from 6 to 5.5 is half an hour. And how you calculate half an hour? You take 6 minus 5.5, right? And this is the change in altitude, right? Which, by the way, reminds me of a question from what, when, where. Right? I'll show you in a moment. More time for the exam? I do not know. Okay, maybe you can get more time for the exam, maybe you can't. Right? Always plan to the situation for the situation where you cannot. Right? I imagine they'll give you like 3 hours, but that's only my imagination. Right? It should, those questions, most of them should take a few seconds. You understand? You look at it like this, and then save the time to difficult questions. You understand? Like, for example, the questions that we solved for the past half an hour together should take you not half an hour. I would want you to do it in 10 minutes, and that's really a lot, very generous, 10 minutes to solve those questions, right? You should solve them in half a minute, honestly. You understand? You look at those questions, bam, 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 right? One of them, let's say, I'm not sure what it means, skip, bam, bam. Where is it? Which of the following could be used to answer a question, how far did the plane descend during the last half an hour? How far? Come on, bam. How far descended? Okay, A, exactly. That takes a second, A. It's the difference in altitude, yes? Good, beautiful. Here's another question. Do we want to do it? It's boring. So here are two functions. Find the limit of g over f where x goes to 2. Should be 2 seconds. Just be careful, guys, which is which, right? So f is the one you divide by, so it's -2, right? So this you can make, because the question is so boring, you can make a silly mistake, right? What you do is you look at g. What is g at 2? Approximately at 2, it's a continuous, so it will be 2. And what is f? It's -1, so it's 2 divided by -1, yes? Now all the others are, again, what is this question? It's the same thing. What is this question? X goes to 3 of 1 over f of x. By the way, let's do this one, right? Third one. Second is boring. Third one, what's the answer? Third one. 1 over f of x, x goes to 3. Yes, but more precisely, what is it, James? Right? 1 over 0 is undefined. All right, so the limit, what's the limit equal to? Okay, so 3 people say the answer is 0. F goes to 0 as x goes to 3. What is 1 over? Yes, it doesn't exist, but be more precise about how it doesn't exist. 1 over 0, yes, but how doesn't it exist? What happens to the numbers as I plug? Yes, that's the same thing. As I plug numbers close to 3, what would be 1 over those numbers? Well, Edwin, you see, x goes to 3. This is f of x. If x goes to 3, f of x will approach 0. You see the altitude, x goes to 3. Either from the left or from the right, I approach altitude 0. What is 1 over f of x? Creation infinity, or look at it. If I approach 3, I'm always positive or negative? Exactly, negative infinity. The answer is negative infinity. Do you see that? Look at it. I am approaching 0 minus. So I would have written this. If I had to do it for myself, I would do this. I would say that for this problem, it is 1 divided by 0 minus. I'm always approaching 0 from the negative direction. Regardless of how I approach 3, it's 1 over 0 minus, and 1 over 0 minus is minus infinity. Are you with me? You understand? So ratio, you are right. The limit does not exist. The point is that it doesn't exist in a particular way, so that we can say a little bit more about it. The numbers blow up in magnitude to infinity, and there is a negative sign. Good? Let's do, what about going to infinity? G of x going to infinity. Gx going to infinity. What am I getting? What's the answer here? Gx going to infinity. Yes, it's 1. The answer is 1. Yes? Gx going to infinity, the answer is 1. What about gx over f of x going to infinity? What's the answer? What's the answer for the denominator? Yes. Yes. Yes, the answer is 0, right? Because g approaches 1 and f approaches minus infinity. It will be a negative type of 0, right? You can write 0 minus, but you can just write 0. 0 is the answer. Yes? It's like always negative numbers, but they approach 0, so we can just say 0 here. Good? Isn't it easy, right? You see what I mean, right? Those are easy questions. Here is another question. Yes? Let's do this one, and then we take a short what, when, where break.
Why is 1 over negative infinity 0?
Because what is 1 over minus infinity? It's 1 over a huge negative number. Right? So if I divide by a negative number, I get negative, but 1 over a big number, it's like 1 over a million. What is minus infinity? 1 over minus a million, it's minus 0.000, you know, right? So it's crushed to 0. It's like if you take $1 and divide it among million starving kids, that each of them is getting crumbs. Nothing, right? A loaf of bread. Right, you will understand it soon. Don't worry. So, what about this graph? Y equals f of x, and g of x is this line. You are asked to find the following, right? So find limit as h goes to 0, g of a plus h minus g of a divided by h. G is this dotted line. Calculate it, please. Very fast. Faster. Would anybody, why does it take so long? Would anybody tell me what is it that we're calculating? Yes, but G prime is not helping you figure it out. G prime is a label. What are you truly calculating? What's the essence of it? What's the nature of the beast? What are we truly doing? When you say G prime is just symbols. It's an obfuscatory language. What are we calculating? Exactly. So slope of the tangent line. And what is the object that we're looking at? A line. Again, what I say is this. I look at this thing and I say, aha, you want me to zoom in near the point. Near what point? Near this point. You want me to zoom near this point at this thingy, this curve, and tell me what sort of slope of a line do you see? Yes? Of this thing. Could it be zero, Rachel? Is it zero? Are you saying slope is zero? If I zoom in at this location, will I see that the slope of the curve becoming a line is zero? This curve is exactly a line, right? This is a line. So the slope of the tangent line is the slope of that very line. So the answer is immediately, simply what you do is here is one point and here is another point. Take 2 points, calculate the slope between them. So it is what? It is 0 minus d divided by a minus c. So the answer is minus d divided by a minus c. That's it. You see, why doesn't it take any time for me? It's not because I can think fast. No, it's just because I realize what is it that I'm being asked. When you realize what you're asked, you can solve it immediately. Are you with me? So I'm glad the exam is like this. So at least in that sense also justifies how I try to teach you. Do you understand, guys? Any questions? Do you understand how I figured it out? You see, when you say G prime or when you have all those obfuscatory language, you forget the essence of this object. What is it about? It's about zooming in on a curve and seeing a segment of a straight line and measuring its slope. That's how it is for us. When you go to differential geometry, you realize again, slope is a really silly thing to measure because change your perspective, your slope is changed. So what you're only describing in is the actual line. You understand? So and having those perspectives gives you a sense of what those subjects are about. Good. Let's continue a little longer. Okay, can you do this? I'm a bit bored, so do the last one. C plus H, this one at the point C here. It's a little bit difficult, but I'll help you if you want. You understand what you have to do? You write this formula and I will show the screen. Yeah, but what is it exactly equal to? It will be negative, you're right. All right. Take care, Yuzu. Okay, James, thank you. All right, so actually your goal is to determine whether it's positive, negative, or zero. They don't torture you more than that. So would you like me to tell you? Here is my question. I asked you to calculate it exactly. I calculate this limit exactly. Can it be done? Can I calculate it exactly? Let me ask you this, guys. How many points determine a line? How many points determine a line?
2.
2, right? How many points do you think need to determine a curve that is slightly more complicated than a line? A line is the simplest curve because you need only, so you have point is determined by 1 point. A line is determined by 2 points. Yes? You understand how I'm thinking, right? Now, what's the next simplest function? How many points do you need to determine it fully? 3. A quadratic is determined fully by 3 points. How many points am I given? 1 and 2. Yes? Because I'm given 1 and 2, I'm not given a third point. I do not know this graph. From those 2 points, I do not know this graph precisely. There is no way I can determine this limit exactly. I can determine it up to a scalar multiple. But it will be up to a scalar multiple is the same as saying, same as saying pretty much any number. But I know it will be negative based on the picture. So you cannot calculate it based on this information exactly. Do you understand how I figured it out? You see, so you might think, well, I'm not able to solve it, or am I able to solve it? But when you reason this way, strategically, you realize it cannot be solved. Good. All right, it's getting boring. So let's do what when where question, and then you decide if you want to go with another one, right? So let me show you. I'm going to pause this and show you one what when where question. Okay. I'll show you the one I solved and see if you can do it. All right, I see you want to escape, Edwin. Then have a good Thanksgiving, if so.
Welcome to DraftKings Thanksgiving. The NFL is on, elastic waistbands are required, and your shot at winning big.
No. 60 совсем не эфирного рекорда. Первый 9 там
Okay.
внимание.
Listen to the question. Are you ready? This should be something you might be able to solve. Can you see the screen? It says it's paused, so I'll share again. I'm not sure what's going on. Can you see the screen? All right, listen to the question. It's a video question.
На экран.
Здравствуйте, уважаемые знатоки.
Hello,
Выпускные
dear
экзамены
viewers.
в британских школах проводятся примерно так же, как и в российских.
Exams in British schools go about the same way as they do in Russia.
Но в последние годы там стало увеличиваться количество жалоб на оснащение аудиторий.
But in Britain, in the last few years, the number of complaints about the equipment of the testing room has increased. They don't like the testing rooms.
Хотя нам с вами это показалось бы по меньшей мере странным.
But to us, Russians, it would appear, in the very least, very strange, this complaint.
Внимание, вопрос.
Attention, question.
Какой предмет заменили в аудиториях по просьбам учащихся?
Which object was replaced in British testing rooms after numerous requests of participants? Okay, the question is this. Again, you have classrooms in Britain, and they are very similar to classrooms in Russia. Doesn't matter, right? That's where you take exams. But in recent years, after numerous complaints by the students, one object was replaced in testing rooms in Britain. And that it would appear to Russians, in the very least, a strange thing to request. Question is, what object in the testing room was replaced? Test, sure, but that's a funny one. But the testing rooms are not one. It's not one test that's going there, right? So and the test is not an object in the classroom. Thank you. So you can turn on the mics and debate with each other if you want. I figured that right away because I know tests.